Okay, so this problem is all killed. So first, I think the first thing to do is not think about probabilities, but instead think about it as a counting problem. So it's a bit easier to think about it as counting the number of ways to assign the inspiration times to like when your friend comes up with the ideas to each problem. So basically, you're coming up, for each problem, you're coming up with the time between 1 and t on when your friend gets the idea to solve the problem. And that's when you'll actually, or you'll like code them from there. So instead of like looking at it as like putting the problems in the queue and solving them lowest to highest, you can do the problems from lowest index to highest index. So for each problem, you look at the inspiration time that your friend solved it. You find the first empty time to the right of that position. And this step can fail if there's like no time left in the contest, like there's no more empty positions to the right. And then once you find that first empty position, you attempt to claim all the time slots from that spot. And this can fail if there's no space. So if you look at the sample input, like 1, 2, 1 in that order, like if the inspiration times are 3, 1, 3, like first I assign 1 at time 3, that's successful. Then I assign problem 2 at time 1, and I claim those 2 spots because those are empty, and that's successful. And then time 3, the last problem is at time 3, and then that's time 3 is occupied, so we find the first empty position to the right, which is time 4, and then that spot is empty, so we can take it. One example that doesn't work is maybe like 2, 1, 5. So at time 2, I try to place problem 1 at time 2. That spot is empty, so I'm able to place it. For problem 2, that spot 1 is empty, so I'll try to claim spots 1 and 2, but 2 is already occupied, so this process fails. And then the last example I have is like 3, 3, 1. So this is kind of an example of like when one of the time slots is already taken, I just scan to the right. This problem formulation is equivalent to the original statement, and it's just easier to think about it this way, just solving problems one by one from lowest index to highest index rather than the time from lowest time to highest time. So now we're trying to place like these problem blocks on like a line. So instead of placing problems on a line, we can try to place it on a circle instead. And we place on a circle with 1 extra time slot. And then basically, since everything's on a circle, we divide the answer by like the number of spots on the circle, because the probability that like the last spot is empty is just the same for all spots on the circle. So why do we put it on a circle? Like the first thing is like the first bullet point where like we first find an empty position to the right, that part can't fail anymore, because like there will always be one thing that's like more like clockwise or like next in the circle. And like this also makes everything like a little bit more symmetric, so a little bit easier to analyze. The second bullet can still fail, so we'll try to count the cases where those will fail and deal with those. So to solve the problem on the circle, we'll place the first block. There's t ways to place that, and it doesn't really matter where. We can kind of rotate the circle afterwards. And afterwards, we'll do something a little bit different, or like a little bit strange. We'll split the circle into n sections, where each section, we don't fix the size of the section. We're kind of saying like, these are the final ordering of the blocks afterwards, after we're done with placing everything. So now when we count how many ways are there to place each block, we look at when the inspiration time, or we can split into 2 cases. Either the first time slot that we look at is empty or it's occupied. So for the second block, there's n ways to place it. If the first space is empty, it has to be at the beginning of the section. And this n is different from like what you might expect like t, like if we just look at it naively. Because like we try to assign it to the beginning of a section, but we just don't know exactly where it'll go. And then if the space is already occupied, there's x1 spaces where we can do ways we can do that. And then this block will just go into the section more directly clockwise to it. For the third block, we can do similar analysis. If the first space is empty, there's n-1 additional empty spaces. So like if we look at this case, it can go in one of these empty spaces, or if it's occupied, there's x1 plus x2 ways to choose that. And actually, if you look at this, it doesn't matter if 1 and 2 are adjacent or not. it'll be the same like number of ways either way. Like we don't really need to care about the where exactly blocks 1 and 2 are, but like the number of ways to choose this is still the same. So like the way you count is exactly the same. And you can generalize that for each block. You get a simple formula. You just sum up like n minus, or like the index plus the sum of the first I things. And then the answer of this problem is just the product of all those choices. Yeah, and that's how you solve that.